solutions. Relation between degree of dissociation or degree of association alpha and want of factor I. Students, first let us consider in the case of dissociation. Dissociation case, we can take the equation as an used raised to na, that means 1 mole of an undergoing dissociation to give n moles of A. Initial moles of an is 1, A is 0. Initial moles of an is 1, A is 0. After dissociation, when we are assuming the degree of dissociation as alpha, assume degree of dissociation as alpha, then the number of moles of an after dissociation is 1 minus alpha. Here mole ratio is 1:n. 1 mole of an is dissociated to give n moles of A. When alpha moles is dissociated, the number of moles of A formed is n alpha. Then the total number of moles after dissociation is equal to 1 minus alpha plus n alpha. Total number of moles after dissociation is, we need to add these two, 1 minus alpha plus n alpha. Want of factor I is defined as observed colligative property divided by normal colligative property. Observed colligative property is the number of moles after dissociation. So I, we can write it as want of factor I is equal to number of moles after dissociation is 1 minus alpha plus n alpha. Number of moles before dissociation is 1. That is, want of factor is defined as observed colligative property divided by normal colligative property. So here we need alpha. So I is equal to 1. From these two terms I can take alpha as a common plus alpha. When we take alpha as a common from this, n minus 1. If we take alpha common from this, remaining term is minus 1. So we can write alpha into n minus 1 is equal to I minus 1. By transferring this 1 to the opposite side of the equation, I minus 1 is equal to alpha into n minus 1. So alpha is equal to transfer n minus 1 also that side. So I minus 1 by n minus 1. This is a relation between degree of dissociation alpha and want of factor I. Generally, in the case of dissociation, I value is greater than 1. In the case of dissociation, I value is greater than 1. Next we will discuss in the case of association. Students, in the case of association, equation, now we have to take the reverse equation, that is Na gives rise to An, n moles of A associated to give 1 mole of An. Initial moles, let us consider A as 1. This equation, for simplicity, we can divide this with the n. So when this equation is divided with the n, so A gives rise to 1 by n into An we will get. When this equation is divided with the 1, by dividing the equation with n, second equation can be obtained, that is A gives rise to 1 by n into An. Initial moles of A is 1, initial moles of An is 0. After association, 1 minus alpha, because alpha moles of A is associated, like that we are assuming, right? Here we can write degree of association as alpha. When alpha moles of A is associated, number of moles of An formed is alpha into 1 by n, because mole ratio is 1:1 by n. When alpha moles of A is associated, moles of An formed is alpha into 1 by n, that is alpha by n. The total number of moles after association is equal to 1 minus alpha plus alpha by n. Again we can write the formula for Vanda factor. I is equal to observed colligative property divided by normal colligative property. Observed colligative property divided by normal colligative property. So we can substitute these values in the expression of Vanda factor I. I is equal to observed colligative properties, the number of moles after association, that is 1 minus alpha plus alpha by n divided by normal colligative properties, number of moles before association, that is a 1 mole. So we need the expression for alpha. So we will take alpha common from these two terms. So I is equal to 1 minus alpha will take common. 1 minus alpha will take common. Then 1 minus, when we will take minus alpha as a common from this, we will get a 1 minus 1 by n. 1 minus 1 by n. Then you transfer this total term to the opposite side, we will get I plus alpha into 1 minus 1 by n is equal to, when we transfer this minus alpha into 1 minus 1 by n to the other side of equation, I plus alpha into 1 minus 1 by n is equal to 1. We need expression for alpha, so transfer I also to the opposite side of equation. Alpha into 1 minus 1 by n is equal to 1 minus I. So alpha is equal to, we can write it as 1 minus I divided by 1 minus 1 by n. This is a relation between degree of association alpha and Bandt factor I. Here the Bandt factor I is defined as observed colligative property divided by normal colligative property. Observed colligative property is the number of moles after association, that is 1 minus alpha plus alpha by n divided by the normal colligative properties, the number of moles before association is 1. So from this we are taking minus alpha as a common, I is equal to 1 is as it is I am writing. From this, when we are taking minus alpha as a common, here 1 we will get. So from plus alpha by n, if you take alpha as a common, minus 1 by n we will get. So in the reverse, if you multiply this, minus into plus is minus, alpha into 1 is alpha, minus into minus is plus, alpha into 1 by n is alpha by n we are getting. Okay, the next step, we want alpha value. So we are transferring this total term to the other side of the equation. So I plus alpha into 1 minus 1 by n is equal to 1. Here it has minus sign. When we transfer to the other side of the equation, we will get a positive sign. So from this, I also transferred to the other side of the equation. So alpha into 1 minus 1 by n is equal to 1 minus I. So finally alpha is equal to 1 minus I by 1 minus 1 by n. So in the case of association, alpha is lesser, sorry, not alpha, I is lesser than 1. Thanks for watching. If you like this video, please do subscribe.